Okay, so let's keep going. And so we're on question number 4. We're still on exam 1 from 2015 fall semester, and we're on question number 14 over here. It says, which reaction below represents the electron affinity of lithium? And there's, as a regular question, it has 5 choices. And since there's really not much to talk about, if you remember what is electron affinity from your classes, it's actually the meaning of how much energy do we need? How the energy we need, energy we need to give an additional electron to a atom. It's a give, as you if you remember correctly, it's give. So the correct answer should be A. As you can see, it's there's only 3 answers over here for giving the electron purpose, and it's A, E, and there's only 3 answers that's been given an electron to the atom. It's answer A, C, and E. And as I guess common knowledge, we all know that if an atom has received an additional electron, it has to have a negative charge. Since an electron has a negative charge, the charge on both sides of the equation has to be balanced. So I would say that A is the correct answer. And since we talked about electron affinity, I guess we can probably go a little bit further about other trends. And if you're familiar with it, you can just close it right now. But just in case I talk about it. So other than electron affinity, there's also, well, I guess we'll just take out our fine periodic table and talk about it. Here, save this first. Here, can we make it smaller a bit? So a little bit smaller, please. Yeah, cool. So there are 4 trends that's what has been generally talked about during the class time, I believe. It's electron affinity, which is the energy. Maybe energy with a big E would be a cooler choice. Oh, what? I can't clean. I have to use the arbitrary eraser, whatever. E of giving an electron. And as this trend, it goes from here, which is the highest, to the lowest over here. So it should be something like this. And I'll try to color it. Oh, can we have a fancy tool for this? Fancier tool? Let me see. Is there a fancier tool I can use? I guess, yeah, cool. There's a over here. Oh, well, never mind. Can we clean it? What? It can't be cleaned. Well, I guess if I click it and it cannot be cleaned. I have no idea. Well, never mind. So this will just be I'll probably just draw them out. So on electron affinity is higher over here, and it's lower on this side. And yeah, by the way, if we're talking about trends, we never include noble gases. So actually, they're just bad people. No, I mean they're just nobles. They don't really get into the game of the commoners, I suppose. So they don't really exist there. Don't pay attention to them. It's higher on this side, and lower on this side over here. I just make a pointy stuff to show that this is like this. It's higher on this side and lower on that side. And there's also other things like did I just lost my words over here? I'll just rewrite it. E of give and electron. And there's also other stuff like let me make it smaller first. Stuff like first ionization energy, ionization energy, which is like the energy of taking off an existing electron from the atom. And this is also follows the same trends of the electron affinity, which, well, I guess it kind of makes sense since the one that wants to receive an electron is less to be willingly to get off an electron. So it's also a trend like this. It's no. Oh, I'm so sorry. I have no idea what I was thinking. So it should be higher on this side, since they don't really want to give up their electrons. Stuff like oxygen, fluorine, chlorine, they're obsessed with their electrons. They want more instead of they want to give them away. So it's much higher on this side for the first ionization energy, and it's much lower on the other side, since these metals like well, this is the francium is a radioactive atom, so it probably doesn't make sense. But stuff like cesium, and barium definitely wants to give up their electrons instead of receiving another one. So it'll be much lower on this side to take off their electrons. So it's higher on this side and lower on this side over here. And there are other stuff like sizes, which is slightly size of atom. Let me change another color so it won't really confuse people, and hopefully I'm not confusing people too much right now. Size of the atoms, which is, well, I guess that you can just, with your imagination, you can understand that hydrogen is definitely smaller than whatever is following, since on this side they have more electrons. So the size increases from here to here. So it's like this. It's higher on this side and smaller on this side. It's much higher. It's bigger on this side and smaller on this side. And for the for going by this direction, so we can know that stuff on this side has a higher effective nuclear charge. Nuclear charge. Oh, look, my handwriting is getting worse and worse. Well, it's kind of hard to write on this side of the board. Well, I can't really see the chemistry resonator sign. I guess it's somewhere over here, and it's probably interfering with something you see, but I apologize, but there's nothing I can do with it. I can't really see it on my screen, so I can't really avoid it. So with the higher effective nuclear charge, they'll get smaller. On this side, it's kind of like there's the electrons on the outside has a stronger pulling force from the nuclear to be like held together, so they'll become smaller. The atom size will become smaller, so they decrease on this side. So it's bigger on this side over here and smaller on this side. So I guess you can probably generalize it as it's bigger over here and smaller on this over here, which kind of follows the trends of the electron affinity. And there's also because Dr. Mao is a very kind chemistry teacher, so we included a graph of the electron affinity, which is the last trend we've talked about. We've talked about during class time, I believe. And the electron affinity follows like this. And please do remember that the idea of electron negativity is artificial, like a synthetic Oh, that's embarrassing. I don't really know how to spell synthetic. Synthetic, I hope it's correct. It's a synthetic or artificial, whatever. I'm not entirely sure which word I should use. It's a synthetic idea or concept that it was given by people, and by how much how much does an atom likes electrons? E minus will probably be easier to understand. Likes to have and likes to, I guess, an atom would like to have an additional electron. So stuff like fluorine, chlorine, and oxygen, they only need like one or two more electrons to complete. They only need one or two more electrons to complete their octet valence shell. So they will be and become one of the nobles. So they would definitely like one or two more electrons, which gives them a very high electronegativity, which like 4.0, 3.5, 3.0. And also, surprisingly, nitrogen also has a 3.0, and other stuff like from here, they don't really want an extra electron. They already want to give up their own electrons, so they have a very low electronegativity. Therefore, the trend follows. This is the lower side, and that is the higher side, and that's the higher side. And we're done with the question. And let me just cancel all the notes.